Hi everyone, how are you today everyone? I wish you're doing okay. We're gonna start today with the new type of applications in calculus, which is physics application. I'm gonna focus on the work. I'm gonna do one problem. I prepared this problem completely. To save your time. This problem is long and hard, but has too many ideas through this problem that will help you in all the aspects of calculus. Let us see, but before we start, let us talk a little bit about what we're going to do. This success learning system. If you have any question, just send us a text message to this phone number or an email. And soon we have SAT classes. If you want, you can subscribe to start receiving our SAT classes. It's going to start in June 25. Don't forget to like and subscribe. Then today we have calculus 2, application integration, physical work. Okay. Let us see the problem first. What's the problem? Just focus on the problem, if you don't mind. I can enlarge it from here somewhere, right? That's too big. Find the work done in pumping gasoline that weighs 4,400 Newton per cubic meter. A cylindrical gasoline tank, 8 meter in diameter and 10 meter long, is carried on the back of the truck and is used to fuel tractors. The axis of the tank is horizontal. The opening on the tractor tank is 5 meters above the top of the tank in the truck. Find the work done pumping the entire contents of the fuel tank into the tractor. Okay, let us quickly, since I see this problem, I'm going to remember my formula. The work is integration from A to B, but for this case from negative R to R, force dy. This is the main formula for any work done. Integration from A to B, right? Fy, F dy, the integration of the force, dy, dx, whatever it is. In my case, the work is double with the weight of the gasoline, right? The weight equal rho times V, the density, because the density given in meter per watt, the density given that weighs 40 Newton per meter cubic meter. This is my density. If you multiply this by cubic meter for the volume, if you multiply this by this density, the rho is this rho, Greek letter calls rho, then this my rho times the volume give you the force. Rho times the volume. Let me go to my board and show you how it look like this tank. Okay, then I'm going to back to this problem. Okay. This is my tank. Let me discuss the problem here and the problem there. This is the tank. This is negative 4 from here. This is negative 4. This is the origin, 0, 0, and this is 4. Good? Okay. This is small piece. There's two variables in my equation, x and y. The fuel goes down, then when the fuel goes down from the tank through this opening here, and this is the ground, from the ground here, which is the green, to the origin, we have 5 meters. From here to here we have 4 meters. From here to here, the diameter is 8 meters. Then 4 and 4. Negative 4 because this is 0. When the fuel goes down, the height changing, the height and the width of that, you imagine it, the fuel is filling the whole tank. The first level of the fuel is going to be like a rectangle with a small width dy. Rectangle, you see the rectangle here, this rectangle here. This is, it should be to the end. Should be to where? To the end. To the end. The length of the fuel never change. 8. The length of the fuel. Now from the formula, I need to find, if you remember the formula, at the end we end up work equal from A to the B, F dx, dy in my case, because y going, the fuel going, y changing. And the work is what we said. Here in my case, the force is the weight of the fuel. W, the weight of the fuel, the weight, dy, and the weight equal rho v. Rho is a constant, dy. V is the volume of the fuel. We need the volume in this small slab. The volume of this small slab. The volume equal length, width, and height. I know the height is what? Related to the y. The height related to the y. And the width of the fuel, which is related to the x and y. I'm going to show it to you right now. And the length never change. This length is what? 8, never what? Change. Or whatever amount of that. Okay. The height. If this amount, let me just move the board here and take what here? A line here, from here to here, right? The height, here to here, okay? And this is the 0. This is 0, right here. Now let us take small section, which is y here, right? Small section, which is what? Y, and this what? X. Y, and this what? The x. This from here to here is y, and that x, right? From here to here, how much, guys? From 0 to the bottom is given to be what? 5 meters. Right? From here to here, how much we have? 4 meters. Which is from the radius of that guy. Now we're taking a small piece to here. We're taking a small piece, which is, I'm gonna make it in the blue, which is the y, right? This is my y, right? Then when you start pumping the total height, you're gonna bump, if you bump y, how much lift always, we have the total from here to here is how much the height? 9, this 9 minus y. Then my height, 9 minus what? 9 minus y. I'm gonna show you the whole in the everything now. 9 minus y. The width. The width, which is related to the radius. Look here. If you take any point here in the circle here, and you take a line from here to here, any line from any point in the circle to the center of the circle, give you what, guys? Give you this, the red is R, and this is X, and that Y, right? This is X, this is X, and this is from here to here is Y. Then the relation between, to find the width of the, you see the width, the small one, right? X squared plus Y squared always equal R squared. Then X squared plus y squared equal r squared, which is 16. We need y. We need solve for y, for x, because the function of y is a function of y. X equals 16 minus y squared, x squared. Then x equals square root of 16 minus y squared. Then I have all my variables. I have all my variables, length, width, the volume of the slab. But the width is not only, if you imagine with me, the width is not only 1x, is 2 x's. X from this side and x from this side. X here and x here. Okay. Let us go to, now you see, this is the slab from where the fuel comes. Small, but I enlarge it to see it. Let us go and see what I have in my solution. Okay. Then we agree. Now, at the limit of integration from negative r to the r, from the bottom of the tank to the top of the tank, and rho dV. Now, let us first what we have to calculate. First calculate the volume of the and weight of the thin horizontal slab. Thin horizontal slab. Vertical cross section of the cylinder tank is a circle with a radius r. That's what I said. Then, if we center the circle at the origin, it has an equation 16 equal x squared plus y squared. Yield 16 minus y squared equal x squared. Yield x equal square root of 16 minus y squared. Is this clear? I think it's clear. Now, the width of the horizontal slab is twice. We have to multiply by 2. 2 times this. 2 times 16 minus y squared. Good job. The volume of the slab, width, length, and thickness. 2. The width, right? The length is 8. Now the thickness, I change it to dy because I'm going to take a small piece. I'm going to take small pieces. dy, 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 till I finish all the tank. Pump all the tank. Weight of the slab, volume times density, and I told you the volume is what? Density is rho. We have here the volume, which is 2, 8, and dy, right? Times the density given 4400. If you multiply 4400 times 8 times 2, you will get 7400 times 16 minus y squared dy. Now, calculate the displacement of each slab. Displacement, that's what I explained there. Here, we have the total is, let us go a little bit back. The bottom of the tank at -4, the top of the tank, y4, spout is 5 feet above the top of the tank. Then at y equal 5 plus 4, 9. We have 5 below and 4 above, total. The displacement always 9 minus y, which is what I explained for you here. Right? From here to here. From here to here is 5. From here to here is 4, 9. Every time we take small piece y, then 9 minus the value of the y. Till you reach to the where? To the 8, right? Till you finish everything. 9 minus 8, which is 1, right? Good. Now calculate the work of each slab, then integrate to find the total work. Work of each slab, weight, time, displacement. Right? 7, which is F dy, we said, right? 7400, 16 minus y squared, 9 minus y dy. Good? Some books, they wrote the work as what to be? Work equal integration for a fluid, especially for a fluid, copy. Can you control V? Control V. I'm going to do it here. I have the mouse. I'm going to show you some books. They write the formula for the work. Control V. they write the work equal from A to B. Sometimes when we have fluids, I'm sorry. Sometimes when they have fluid, they write the formula. Just keep this formula from A to B rho the area and rho A as a function of y or x, because I have y, I'm going to put as a function of y, h as a function of y. If you have x, you change y to x, dy, sum box, which is the same as rho, because look here, which is the same as the volume. Yani sometimes you go directly, you find the area, hy dy rho, which is the same thing, rho v, which is the same as rho v dy, from A to B, whatever limit you have. I'm going to change my A to B, whatever limit you have. Whatever limit you have. This is another formula, and you can use, and you can, actual AHY is the same area of the base times the height equal the volume. This is basic geometry thing, right? Basic geometry formula. Rho comes to make rho v is what give you the force. Then the work of each slab, the weight time what? Displacement. Weight time displacement. Good? And I give you the two formulas. In my case, I will not use this. F is the weight, the force here is the weight, and rho v, and the v already I found it here, the volume, which is here. What is the volume? Here, the volume, volume is here. 2, 8, weight, already I've multiplied the volume of this guy by the density, which is 4400. Then I have all this slowly, you do it from A to Z. Now here, then we have it from negative R to R. 70, we're gonna move a little, a small y, 9 minus y, till you finish the whole tank dy. Now, we're gonna do here, now at this point, we're done with the physical application. Now we need to integrate. I meant to finish the problem for you, and you're gonna finish it at the end. I meant to finish the problem for you, to review with you the trig substitution. This is, we can use y equal 4 sine theta, right? Y equal 4 sine theta. Y equal 4 sine theta. And this is basic of trig substitution, right guys? Y equal 4 sine theta. Now change the limit when y equal negative 4. When y equal negative 4 here, if you change this y to negative 4, 4 divided by negative 4, sine theta equal negative 1, that yields theta equal negative 3 pi over 2. When y equal 4, 4 divided by 4 is 1, sine theta equal 1, sine theta equal 1 when theta equal pi over 2. Now, what else you have to find? dy. If y equal 4 sine theta, dy equal 4 cosine theta d theta. Then go to this integration, change the limit from negative 4 to 4, negative 3 pi over 2 to pi over 2. Don't touch this number, take it out, is a constant. From negative 4, 16 is 16, and y is 4 sine theta, becomes 4 sine theta square, times 9 minus y is 4 sine theta. From here, y is 4 sine theta from the trig substitution, and dy equal what? 4 cosine theta. Integration of, derivative of sine is cosine. Now, what's 16? I took 16. This 4 square becomes 16. Look what I did. This is 16. Let me just make it red or blue. And this 16. And this 4 square is what? 16. How many minutes I have? 16.
8.
8, huh? Okay. 16. 16. Left 8 minutes for me or what?
It's at 20 right now.
It's 20. Okay. Then 16. Then this 16. 16 when it goes out of the square root becomes what? Here, look here. This with this. 16. When you take it out, becomes 4. Right? And here left 1 minus sine square theta. Now, and here 9 minus 4 sine theta, cosine theta. Now, 1 minus sine square, what 1 minus sine square equal? I'm gonna do it like this, in the side, this only, copy. And this here, for you guys, this becomes cosine square theta. Cosine square theta, and this is equal cosine theta only. Cosine theta. Okay. Should be out of the square root. Equal cosine theta. Okay. Now that's what I did here. 9. Then I multiply. Look here. Watch me very well. The 4 times this becomes this. Negative 3 pi over 2. 36 cosine theta. 9 minus 4 sine theta. 4 cosine theta. If you multiply, watch. 4 times 9. What 4 times 9? 36. Cosine times cosine square. 36 cosine square theta. This is the first integration you're going to do. The second integration you're going to do is when you multiply which one? Cosine and sine and 4 cosine. 4 times 4, 16. Right? Cosine times cosine. You can do this. Okay, I'm going to do this another step to show you what I did. I'm going to do this another step here, and just if you multiply, this is going to be 4 here, and this becomes cosine square theta, because you multiply cosine square theta. Cosine square theta, and this no more, only d theta. In this step, I multiply 4 cosine theta times this, 4 cosine square theta. That's what happened. When you multiply 4 cosine square theta times 9, 36 cosine square theta. When you multiply 4 times 4, 16 cosine square theta. Now how we deal with this? This guy here, I'm going to do it again one more time. This 36, this equal, if you remember the cosine formula, cosine square equal half equal half 1 over 2, right? 1 plus cosine 2 theta, right? Cosine 2 theta, right? Cosine square and sine square equal the same, right? And this becomes let me just minimize it to stay. And this is, if you multiply 36 times half, is 8. This is going to be 8 only. 8 from this and this. 8, and this easy to integrate it. And this we're going to use a strict substitution for this integration. This is easy. This becomes the first integral. I'm going to take this guy. You're going to finish it. This becomes, for the first one, I'm going to take this guy here. 8 theta, 8 theta, and plus integration of cosine is what? Sine, right? 2 theta, but we have 8 sine 2 theta over sine 2 theta over 2. This for the first integral, for this one. Okay, I'm gonna highlight this. Okay, highlight it with, okay, and this is for this. Okay, let us go to this one here. This guy for here, we're gonna do something. We're gonna do something for this. Just keep the time with me. We're gonna take u equal, right guys, u equal cosine theta. U equal cosine theta. Cosine theta, right? Then du equal negative sine theta, negative sine theta, d theta. Solve for d theta here. Solve for d theta equal du over negative sine theta, right? Du, how much?
It's at 28 right now.
Du over, what is stop limit? Du over negative sine theta. Okay. Then this guy becomes forget the limit. I will remove the limit to the end. This is 16u squared u squared, right guys? And you're gonna finish it by yourself. Now if you need me to finish it, just send me what, and d theta equal du and du control v, and this guy cancel. We're gonna cancel with this equal, this is equal to only what, negative 16 integration of 16u squared, right? U squared controls du, which is equal negative 16, right? U cube, okay, negative 16, and here u cube